and thank you very much for joining us. I am Dr. Gauchotte-Lindsay from the University of Glasgow, and I'm here to welcome you on behalf of the Royal Society of Chemistry to this special series around chemistry and climate change. As we look forward, as you will, most of you know, we'll look forward to COP26, so the United Nations Climate Change Conference that is happening early November in Glasgow, so in my town. For nearly 3 decades, the United Nations have been bringing together people from almost every country in the world to discuss climate issues in that global climate summit, and the Royal Society of Chemistry wants to play a role in showing how chemistry has a vital role to play in terms of climate solutions. And so we have been organizing this series of online events as we build up to the COP. This session is recorded, as well as all the other sessions, all the other panels. And so most of you will probably be watching us on the recording. If you want to access the rest of our program, you can look at the website. So it's the link was on the site you just saw, but it's rsc.li/COP26. So today I'm really pleased to welcome our panel of experts to discuss the chemistry of natural-based solutions to climate change. Natural-based solutions involve the protection and restoration of ecosystems with the intention of slowing further climate change or adapting to the effect of climate change. By this we might mean a range of different ecosystems, such as untouched forests and wetlands, but also city parks, mangroves, agricultural lands, to be managed for the benefit of the biodiversity and of people. So in this panel, we will introduce the concept of natural-based solution, and in particular discuss the processes of storage and chemical flow occurring in the different ecosystems. So today with me, I have Dr. Cécile Girardin of the University of Oxford, who is the Technical Director of Natural-Based Solutions Initiative, Prof. Pete Smith from the University of Aberdeen, who is a professor in plant and soil science, and Dr. Bill Austin of the University of St. Andrews, who is the chair of the Blue Carbon Forum. We'll do a Q&A at the end of the session, so our panel will first present to you their research related to natural-based solution, and I'll introduce the concept for about 10 to 15 minutes each, and then we'll take questions for the panel at the end. So you'll see at the bottom of your screen on your Zoom bar the Q&A tab. Can I invite you to use this tab to ask questions? And at the end, I'll pick, hopefully, there will be many questions, and I'll pick some of them to be asked to our panel. So again, use the Q&A tab. You can ask a question to a specific speaker. And if you want to do this, it will help me if you write down who you want the question to be asked for, although I probably can figure it out. But you can also ask general questions to all members of the panel. So first of all, I'm very pleased to welcome Dr. Cécile Girardin of the University of Oxford to give an overview of natural-based solution. Cécile is the science lead of the Oxford Biodiversity Network, and as I said, the Technical Director of Natural-Based Solution Initiative. She combines years of experience in climate change policy analysis with a background in tropical ecology and thorough understanding of forest ecosystem, functioning to provide a unique multidisciplinary approach to our work. Our research focuses on the potential for natural-based solutions to respond to climate change. So, Cécile, I give the floor to you. Good morning.
Good morning, Caroline. Thank you. I'm going to share my screen. Thank you, and thank you for inviting me. It's a delight to be here today. As Caroline said, nature-based solutions to climate change. I'm going to introduce the concept and how much they contribute to climate mitigation and adaptation, and before my colleagues dive into the chemistry of nature-based solutions. So put simply, nature-based solutions involve working with nature to address societal challenges. And this is to provide benefits for human well-being, as well as biodiversity, as well as climate change mitigation and adaptation. So specifically, there are actions that involve the protection, restoration, and management of natural and semi-natural ecosystems, as well as the sustainable management of working lands. As you can see in this diagram, we try to represent everything here. The sustainable management of working lands, of aquatic ecosystems, and blue-green infrastructure in urban areas. So when we're talking about these ecosystems, semi-natural or human-modified, as well as intact ecosystems, we're talking about everything from kelp forests to peatlands, seagrasses, coral reefs, as well as agroforestry and urban green blue infrastructure, just to make it clear. So the concept of nature-based solutions is rooted in the understanding that ecosystems support societies in multiple ways. And this is, includes food security or water security, carbon storage, carbon dynamics, protection from climate extremes, and improved human health, etc. And the concept also arises from the understanding that biodiversity and biodiversity loss and climate change, which are two of the biggest challenges we're facing this century, share some of the same drivers, as well as some of the same solutions and these are rooted, could be addressed by nature-based solutions. So whilst the ultimate goal of nature-based solutions is to support sustainable development, the ecosystems that provide these services can only do this if they are healthy and functioning ecosystems. And this is what we need to focus on for gaining these benefits in the long term. And this is the catch. So this is something we need to address again and again, is that some projects that may be flagged as nature-based solutions, for example, I'm thinking about tree planting on a very large scale to maximize rapid carbon gains, may have negative outcomes for other aspects of what we look at when we're looking at nature-based solutions. So may have negative outcomes for biodiversity, because I'm thinking here of monoculture plantations that would replace, or that could be replaced by a healthy, diverse, complex ecosystem, a savanna or a grassland or a forest. And it could have negative impact for local communities. There are many instances of ignoring or sidetracking land rights for large-scale plantations, for example, and also has negative effects for the climate, because in the long term, you may get a rapid carbon gain in the short term, but in the long term, monoculture plantation that is managed purely for carbon will not be as resilient to rapidly changing climate as a complex, thriving, healthy, functioning ecosystem. So these are examples of nature-based solutions that we have, just to put this in context. Very quickly, we have examples of cocoa agroforestry in Sierra Leone that have shown more profitable yields, improving local livelihood, avoided deforestation that protects biodiversity and saves avoids carbon being emitted. Community wetland restorations in the Peruvian Andes was another example where we found increased carbon storage, improved water supply, reduced erosion and landslide risk, and improved habitat for wildlife, as well as improved water regulation, etc., which makes livestock more resilient. And another example is an urban forest in the States, where they find that increased tree cover in parks and pavements significantly reduces daily temperatures during heat wave, increasing carbon sequestration, improving human well-being. There are many, many examples that you can find by surfing Nature-Based Solutions Initiative case studies website. And there's just a growing evidence base around all these projects that have multiple benefits, and the projects we are looking for are those that have benefits for climate, biodiversity, and human well-being. So with all this in mind, there's been a lot of focus on nature's role in mitigating climate change. So how much do nature-based solutions, how much do ecosystems contribute to mitigating climate change? As I said, they're widely viewed as a win-win strategy to address climate change and biodiversity loss, as well as social equity. But the potential contribution of nature-based solutions to mitigating climate change still remains somewhat controversial. And we do need to know how much could nature-based solutions contribute to mitigation. And to answer this, we've looked at it in a way that is in a context relevant to the Paris Agreement, in the context of limiting peak warming to well below 2 degrees this century, whilst pursuing efforts to limiting warming to 1.5. And to answer this question, we focused on a model provided by in Griscom et al. 2017, which is a well-constrained model that looks at the cost-effective climate mitigation for nature-based solutions on land. So we're focusing on terrestrial ecosystems here, and we're focusing on cost-effective mitigation. So that's at a cost of less than, if society is willing to pay up to $100 per megagram CO2 per equivalent, this is what we would expect. So nature-based solutions, according to this model, and these are updates from the 2017 models here, nature-based solutions could save up to 10 gigatons of carbon dioxide equivalent per year. And what's interesting here is to see how this can be divided, this is divided in avoided emissions and enhanced sinks. So in terms of avoided emissions, the majority of this comes from protecting intact ecosystems. So protecting forests, grasslands, peatlands, and more, and all these terrestrial ecosystems in this case. There is also quite a significant portion that comes from avoided emissions from better management of working lands. So better management, sustainable management of land for crop, grazing, timber. And only 20% of this comes from from restoring forest cover, forest, wetlands, etc. So restoring ecosystems. And it's interesting to see that there's been such a big focus recently on restoration of ecosystems for carbon offsets, for example. I'm thinking of the carbon offset, booming carbon offset market. But it's good to put it in context and see that 20% of the total nature-based solutions benefits, mitigation benefits, come from restoring cover, whereas we should really be focusing on protecting intact lands and better management of working lands. So these estimates come well constrained. The constraints and safeguards that need to apply to these models are super important, because you're not looking at, we do need to include biodiversity safeguards, for example, restore forest ecosystems in areas that are ecologically appropriate for forests, exclude boreal biomes due to albedo. We need to take into consideration the saturation of ecosystem carbon sequestration rates. Also, of course, food security, fiber security, and then the complexities of governance issues such as land rights, conflicts between land ownership and management, and inequalities that are experienced in the regions where investing in nature-based solutions. And all this is very sensitive to cost. So if society is willing to pay more, we will end up with bigger mitigation potentials. And to answer the question of how nature-based solutions will contribute to limiting peak warming to well below 2 degrees this century, whilst pursuing efforts to limiting warming to 1.5 degrees C, so the Paris Agreement requirements, we entered this model into the IPCC model. So this is the first figure you see in the IPCC work summary for policymakers. The straight line you see here is the IPCC model. So the blue line is where you peak at 1.5 degree, and the dark blue navy line is where we peak at 2 degrees C. These are the two trajectories described in the IPCC model. When we add nature-based solutions to that, we get the dashed line. So in a scenario where we peak at 1.5 degree in mid-century, the addition of nature-based solutions reduces this by 0.1 degree C. And in a scenario where we peak at 2 degrees, we get a reduction up to 0.3 degrees C. And importantly, you can see that nature-based solutions for mitigation need time to act. So in the short term, we get a real but limited reduction in warming. But in the long term, they continue acting up to the end of the century and have an important role in cooling the planet. So the take-home message here is that we need to act now, but think long-term and invest in projects that will be resilient in the face of a rapidly changing climate, that will continue to store carbon and to be carbon sinks. So the mitigation potential of nature-based solution is time sensitive. We need to scale up nature-based solution now, but in ways that that will reap benefits for the long term. So that's taking into account the long-term storage potential of carbon, of course, but also the way they're developed with the communities that are the stewards of these projects. And nature-based solutions play a critical role in cooling our planet up to the end of the century, but we will only get this full mitigation and adaptation and sustainable benefits if we invest in activities that are ecologically sound, socially equitable, and economically viable. And that's it for now. Wait, let me. So these are just conclusions from the study. We found that the model reinforces the conclusions that an ambitious scaling up of nature-based solutions need to be implemented fast and thoroughly, but not at the expense of other measures. And that means not replacing greenhouse gas mitigation. So keep fossil fuels in the soil rather than offsetting them later. Nature-based solutions can provide real but limited mitigation benefits in the short term and have a powerful role in reducing temperatures in the long term. So they must be designed for longevity. And then the other side of this analysis is that decades of work provide strong evidence that nature-based solutions can deliver a multitude of local ecological and socioeconomic benefits. And we have a paper published by Gauchotte et al. From the Nature-Based Solutions Initiative that collates information from hundreds of studies demonstrating this. So we find that nature-based solutions can help people adapt to climate change whilst achieving the sustainable development goals, protecting biodiversity and mitigating climate change. And that's in terms of protecting ecosystems, defend against storm surges, saltwater intrusion and erosion, for example. We have a lot of evidence around the fact that restoring forests and wetlands secures and regulates water supplies, shields communities and infrastructure from floods, erosions and landslides, and also improved management. So nature-based agriculture, such as agroforestry or the beautiful example of floating gardens, can increase resilience of food supplies and increase resilience to pest, disease, climate extremes. And creation of green and blue infrastructure in cities help cool and flood abate and help with cooling, as well as flood abatement, reduce air pollution and provide health benefits. So I don't need to go into this into too much detail, but there's a strong case for the fact that biodiversity is a core component of our society as well as our economies. There's also a big movement towards the carbon offsetting market, and in some cases, the focus is very strongly on reforestation and afforestation, which presents problems. We really need to focus when we're looking at these projects, at nature-based solutions projects. We need to understand that the key metrics are biodiversity as well as climate and social equity. And we need to look at a range of ecosystems, the right ecosystem in the right place is the message. I won't go into this into much detail, but one clear and message that comes out of all this is that as the negotiations are coming up in COP26, we do need a clear voice on what successful and sustainable nature-based solutions are. So there are several guidelines coming that have been published, one from the Nature-Based Solutions Initiative that highlights 4 governing principles of implementing nature-based solutions. There are also IUCN guidelines that are very comprehensive, the WWF principles, the World Bank principles, and etc. And that's it. I'll stop here. I think I'll take questions.
I think we'll, thank you very much, Cécile. I think we'll keep questions for the end, but please, if you have questions for Cécile, can you put them in the Q&A? Thank you so much. It was a great, well, you literally planted the seed, so thank you very much. And also for your fabulous hard work, it's wonderful. As I say, please, if you have questions for Cécile, put them in the Q&A now, and we'll pick them up at the end in our panel discussion. Our second speaker today is Professor Pete Smith, who is a professor of plant and soil science at the University of Aberdeen. Scotland is heavily represented today, that's great. His main areas of expertise are in modeling greenhouse gas carbon mitigation, bioenergy, biological carbon sequestration, global food systems modeling, and greenhouse gas removal technologies. He was convening lead author of IPCC Special Report on Climate Change and Land 2016 to 2019, and Science Director of Scotland's Climate Change Centre of Expertise. So I leave the floor to you, Pete.
Thank you very much. I'll just try to share my screen.
Yeah, it's
Here we go. Thank you. Thank you, Caroline. So today I'm going to be talking about carbon flows and the other benefits from nature-based solutions in terrestrial ecosystems. And Bill later is going to cover the coastal and blue carbon ecosystems. So I'll just deal with the terrestrial ones at the moment. So that was an excellent introduction to nature-based solutions from Cécile. So what I'm going to talk about today is the nature-based solutions for greenhouse gas removal in the land sector, and some of those which are also nature-based solutions. So as Cécile has already explained, there's not a one-to-one overlap between greenhouse gas removal and nature-based solutions, but some land-based solutions for climate change can also be nature-based solutions. So I'm going to explore today 3 of those, mainly planting trees, so that's afforestation, reforestation, soil carbon sequestration, and the restoration of peatlands and wetlands. So as you can see on this slide, greenhouse gas removal technologies or options can be conceptualized across a spectrum, with those natural greenhouse gas removal options shown on the left of the slide in green, and 3 of those that I'm going to talk about today. But the others are over on the technological side. There are technological solutions which also need to be considered, such as direct air capture, ocean alkalinity enhancement, and CO2 into durable carbon products and enhanced weathering. These are more sort of technological solutions, which can also be employed to remove greenhouse gases from the atmosphere. I should say that the technological solutions tend to be more costly, and they're at a lower technology readiness level, so there are greater research and development needs. But when you've locked the carbon away, it's in geological storage, so it tends to be less vulnerable to reversal. On the other side of the screen, these natural ones that I'm going to talk about today tend to be less costly. They tend to be closer to deployment, because we know how to manage our soils, we know how to plant trees. We've been doing that for millennia, but they are more vulnerable to reversal. you know, if you plant trees and you get a forest fire, then you can lose all the carbon that you sequestered whilst the forest was growing. So there's these pros and cons associated with the various aspects of greenhouse gas removal. I personally think that we need to invest in both the technological and the nature-based solutions, but it's the nature-based solutions that I'll focus on today. Cécile mentioned the study by Griscom et al., which was Natural Climate Solutions, that was published in PNAS in 2017. And this really captured the imagination of the policymakers, because it suggested that maybe 25 to 30% of all the greenhouse gases that we emit into the atmosphere could potentially be sequestered in nature, in natural climate solutions, so in the land and the ocean. So here is a graph of the technical potential. I should say that 25 to 30% is a technical potential. Not all of that is going to be realizable, because there are many barriers that stops that happening, and even less of that is available at low cost options. So in the grey bars is the very low cost portion. In the light grey is the what we need to get it below 2 degrees Celsius, and what's shown in the empty bars, the white bars, is the sort of technical potential that's achievable if we max out all of the options. As you can see, most of the options that exist are within forestry, agriculture and grasslands, and in peatlands and wetlands. So in the forestry sector, for example, there are things like natural forest management, improving plantations, reforestation, avoided forest conversion, and fire management, for example. In agriculture and grasslands, it tends to be mainly sequestering carbon in the soils, and that's one that I'm going to focus on a little later, but does include some above ground vegetation carbon. So that's agroforestry, for example, trees in croplands, that sequesters carbon both in the vegetation and in the soil. And wetland and peatland restoration are things like avoiding future impacts and also restoration of degraded systems. But as Cécile's already mentioned, only a proportion of these can also qualify as nature-based solutions. So it really depends on the way that you do it. So if you reforest an area, for example, that was previously forested with native trees in a way that's conducive to promoting biodiversity and also involves the local community, that could be considered a nature-based solution. If, however, you force people off the land to plant it up with monoculture plantations, that would be bad for biodiversity and bad for people, and that wouldn't be considered a nature-based solution. So what we can do is we can take the greenhouse gas removal options that are available, these natural climate solutions, and we can work out how to implement them in a way that would also ensure that they were nature-based solutions, and also delivered other co-benefits for other ecosystem services, and also make a contribution to the Sustainable Development Goals. So as Cécile already mentioned, the nature-based solutions can be categorized in terms of those that protect existing high carbon and high biodiversity ecosystems. So these might be our permanent grasslands, our woodlands and our peatlands. Restoring the degraded high carbon and high biodiversity systems. So degraded peatlands, for example, forests, coastal marine systems, which Bill will talk about in a moment. So we know that, for example, 80% of our peatlands in the UK are not in pristine condition, and they're degraded to some extent. So there's a great potential to restore them, make them better for the biodiversity, and to switch off the large carbon source that they are currently. We can better manage our woodlands and our soils. So as Cécile showed, about 40% of the potential globally is in land that is already managed. It's not in these pristine systems. So it's not just about conserving nature or protecting nature or restoring nature in pristine ecosystems. It's about also better managing our managed land, we still need to produce timber, we still need to produce food. So we're going to have some proportion of our land that's managed to produce goods that we need, but we can better manage those for biodiversity and for people. And the last one is to create things like new woodlands or create novel ecosystems in urban environments, for example by putting using vegetation to cool buildings and to change the reflectance of certain areas and to cool urban heat islands. These sort of creation of novel ecosystems can also contribute. When we add them all together in the UK, we've got a carbon stock in the land is around about 16,000 megatons of CO2 equivalents in the UK systems. So over 10,000 megatons of that is already in our peatlands. So protecting our peatlands will have a great contribution to our climate change mitigation by keeping the carbon in the soil where it belongs. We can also restore our degraded peatlands, which by 2030 would give us around about 23 to 34 megatons of CO2 equivalents. We can better manage our croplands by improving agroforestry, by putting trees into the landscape and re-establishing hedgerows, and that could give us 9 to 18 megatons of CO2 by 2030. And we can also create nature-friendly forests and woodlands, which would give us about 44 to 71 megatons of CO2 equivalents by 2030. And scaling that out to 2050, it could save us up to between about 300 and 500 megatons of CO2 in total additional mitigation potential out to 2050. So it can be a significant contribution to our march toward net zero in the UK. By protecting our ecosystems, as I mentioned already, existing land sinks are about 16,000 megatons of CO2. 85% of those carbon-rich peatlands also deliver biodiversity benefits. So by protecting these ecosystems, we're pretty sure that we could deliver that in a way that also constitutes nature-based solutions. The remaining 50% is mixed or context specific in terms of the nature benefits. For example, there's some overgrazed grasslands in the permanent grassland category, which wouldn't necessarily at the moment constitute a nature-based solution. But if implemented in the correct way, that could really enhance biodiversity as well as being good for the climate by sequestering carbon. And so if implemented in a sensitive way, that could also deliver to nature-based solutions. And in the restore, manage and create categories, restoring degraded peatlands, forests and coastal systems could give us emissions reductions of up to 60 to 122 megatons of CO2 by 2050. And restoring peatlands, for example, eliminates the most substantial emission source, because a hectare of peatlands, which is badly degraded, can emit in excess of 30 tons of CO2 per hectare per year. And that's several times your average family car's annual emissions of CO2. So that's the equivalent of taking several cars off the road just for a hectare of peatlands. We can better manage our woodlands. We can sequester between 26 and 43 megatons of CO2 by 2050, creating new woodland as cumulative emissions reduction potential of about 190 to 330 megatons of CO2. And when we look at these about how they contribute to biodiversity, about 40% of the actions to restore, manage and create carbon-rich habitats can be regarded as nature-based solutions. And the remaining 54% could enhance biodiversity if implemented carefully. But as I mentioned earlier, it's all about the way that these options are implemented will determine whether we get a nature-based solution or whether we simply get carbon removal. And it makes sense to obviously maximize the co-benefits that we get. And we can also look to see if they contribute positively to other ecosystem services and to the Sustainable Development Goals. And here's an example. So this is looking at peatland peatland and wetland restoration. So we have the functions provided on the inner ring of the pizza. So the wetland functions, for example, climate mitigation, flood abatement, habitat for biodiversity, an area for recreation, these 6 functions. We can map these onto nature's contributions to people or the ecosystem services that are supported by these functions. So the 6 functions that wetlands and peatlands provide contribute to these 18 ecosystem services or nature's contributions to people. And shown in the little green, the little blue dots here are the particular function that contributes to this particular ecosystem service. And then as we move from the middle ring to the outer ring of this diagram, we've got the 17 Sustainable Development Goals around the outside, and the contribution of these ecosystem services are shown here in the dark blue circles to the contribution to each of these ecosystem services. So, for example, number 3 is healthy lives, and that's contributed to by a whole number of these ecosystem services, which in turn are contributed to by the functions. You can see that there's mostly positive impacts on all ecosystem services and the Sustainable Development Goals, but there are possible local negative impacts, for example, by taking land out of food production, which could compete with land that's used for growing food and could negatively impact SDG 2, which is about ending hunger, for example. So there are these some potential negative impacts which could be mitigated if implemented correctly, but it shows that there are mostly co-benefits, but a few trade-offs. We can do a similar thing for afforestation and reforestation. And this is another example showing how we got the functions, the ecosystem services, and the contributions to the Sustainable Development Goals. And again, we get mostly positive impacts. We can have some variable impacts, for example, on zero hunger, and we may have some potential negative impacts locally on those SDGs that rely on economic growth. So ending poverty, for example, could be slowed by reducing deforestation in some areas where that's providing economic activity. So all of these things have to be taken into account. The last one that I'm going to cover is soil carbon sequestration. And this is an easy story to tell because it has entirely positive impacts on all of the Sustainable Development Goals and all of the ecosystem services that are provided by the functions of soil carbon sequestration. So this appears to be pretty much a no-brainer in terms of providing positive contributions to a whole range of societal goals. So in summary, I'd like to say first that the land can't do it all. So I think there's been a bit of hype, a bit too much hype, I think, about nature-based solutions and natural climate solutions, saying that we can use nature-based solutions as a way to tackle climate change. It's really important that we do use them to tackle climate change, but it just doesn't take up the whole of the emissions that we emit from transport, energy generation, and aviation. We need immediate and aggressive action to reduce those emissions across all sectors of the economy, after which the nature-based solutions can help us mop up the remaining emissions, those very difficult to abate emissions, for example, emissions of non-CO2 greenhouse gases from food production. So we need immediate and aggressive action across all sectors, and we use the nature-based solutions in addition to those, not instead of. Not all land-based greenhouse gas removal constitute nature-based solutions, as I already mentioned, but most can deliver benefits if implemented appropriately. However, if poorly implemented, many land-based greenhouse gas removal options could harm biodiversity and ecosystem services and the SDGs, so appropriate implementation is absolutely crucial. But if implemented carefully, nature-based solutions are good for biodiversity, good for people, and good for both climate change adaptation and mitigation. So it's a matter of just making sure that we really get it right when we implement them. And the last thing to say is I've spoken about terrestrial systems, but there are also ocean-based approaches which are comparatively under-researched, and I'm going to leave that to Bill to explain because he can do a so much better job than I can on those particular aspects. So thank you for listening. I'll stop sharing now and hand over to Bill.
Great, thank you very much, Pete. There's a very nice picture that's a drawing here with the interconnectivity with social equity and the fact that natural-based solutions are not necessarily the silver bullet. So as Pete was saying, our third and final speaker this morning is Dr. Bill Steen of the University of St. Albans. His research focus. His research focus is directed primarily at reconstructing past climate change from land and coast, with a growing research interest in the use of biogeochemical proxies for paleoceanography. He was recently funded by the British Council to lead a project on blue carbon in the UK seas and coastline, and this is what he's going to talk to us about today. So, good morning, Bill, and over to you.
Thank you, Caroline. Good morning, everyone. And thank you to Cécile and Pete for wonderful presentations. I am going to present on opportunities for blue carbon. And I think I should acknowledge, as Pete highlighted, that this is a rather under-researched area, but currently one that's attracting a great deal of interest. I'm going to present this morning on a particular habitat type to illustrate the concept, but I should say at the moment that I'm spending a lot of my time thinking about how to consider the improved management of our shelf seas. And our shelf seas store vast quantities of carbon. They're poorly managed, and there are impacts on what we might consider irrecoverable carbon, which have very significant implications for our climate system. But I won't focus on those issues today. Instead, I'm going to focus on a habitat here in the UK. It's widespread globally, called salt marsh. And unlike the terrestrial habitats that Pete has just highlighted, these are probably 2 orders of magnitude less in terms of their mitigation potential, yet they provide a nature-based solution that I feel our governments, should embrace as a signal of our commitment to nature. And I would like to highlight again the points that have been made, that nature-based solutions offer opportunities for climate change, for people, and for biodiversity. So in this first slide, a student has summarized conceptually the way in which nature, in this case salt marsh plant communities and these habitats, provide a sink for carbon and create a long-term store. So a little analogous to those carbon stores in our peatlands that Pete has just recently highlighted. So the oceans, we know, are extremely important in the cycling of the global carbon cycle. About 83% of that carbon passes through our oceans. In terms of coastal habitats, they only cover about 2% of the area. And yet we understand that about 50% of carbon sequestration occurs into these sediments initially. So area for area, these are going to be very effective places for carbon, and as blue carbon habitats, they've been gaining a great deal of interest in recent years. If I showed you for a moment the annual carbon sequestration rates for these blue carbon habitats, these are defined by mangroves, tidal marshes, and seagrass meadows, and compared these to our tropical, boreal, and temperate forests, area for area, we see very significant increases in sequestration rates in these blue carbon habitats. And again, when we look at the same habitats and compare them to boreal and tropical forests, but now consider both the living biomass in light blue here, and the associated soil organic carbon stores in these habitats, again, area normalized, we see very important blue carbon stores in the soils of these habitats. So these are highly productive marine coastal systems, and they also are very effective places to store and preserve carbon in the long term. Now, some of the work that we've been doing as part of a UKRI project has been to establish here in the UK an improved carbon stock in the soil of these habitats. And this is work that's ongoing, but we've recently published a soil stock assessment for Scotland, and we're currently working on the wider UK stock. Now, these habitats do fall within current frameworks. So in the context of this seminar today and our focus on COP26, I've chosen salt marsh habitats in the UK because they're reasonably well mapped. As I said, we have a growing and improving understanding of their soil carbon stocks. And under the frameworks set out by the Intergovernmental Panel for Climate Change and something called the Wetland Supplement, under which this habitat and peatlands, of course, fall, we have a guidebook framework that allows us to incorporate these habitats through an understanding of land use change into our national greenhouse gas inventory. And this, of course, as both speakers have already highlighted, points to the fact that these nature-based solutions in habitats which are managed to provide additional carbon, that's the additionality, and a permanent store, provide an opportunity for governments to account for the greenhouse gas sink into these habitats. So of course, this is very useful in the net zero agenda of government to help with conservation measures to improve and therefore restore these habitats. I chose an example here from Nick Bay. It's an RSPB reserve in Scotland, up in northern Scotland. It's a relatively small site, just 25 hectares. It's also one of Scotland's first managed realignment sites. And the photograph shows a golf hole cutter, so it's removed a core of soil from this site. The existing seawall was breached in February 2003. And what we see in the layering here, over 10, 15 centimeters or so, is the transition to an organic, rich salt marsh soil. And the vegetation at the very surface here is part of an upper zone in the intertidal salt marsh habitat that now exists at Nick Bay. And we see in this plot of simply the percentage organic carbon measured in those soils, an increase up core after the restoration of this once reclaimed salt marsh habitat. So one of the challenges for us, I think, is to understand some of the chemistry of the soils, particularly the way that organic material is incorporated, is broken down, and then ultimately stored in the long term in these habitats. But I think this is a very encouraging record from NEG, showing us that management interventions can enhance the carbon storage in the soils in these places. Now, of course, once we know the stocks of these intertidal blue carbon habitats, in this case, an example from southwest Scotland near Wigtown, we can apply, using the methodology of the IPCC, what are called emission factors. And we have these in different tiers, in different levels of detail. But one of the points of this slide is to highlight that we can move quite quickly. Once we've mapped the habitat, we've understood the carbon stocks, we can move quite quickly towards the implementation of the habitat into our greenhouse gas inventory. But we also need to understand the emissions from these habitats, the greenhouse gas emissions that naturally occur. And one of the things that this cartoon diagram, actually from Joe Smith, Pete's wife at the University of Aberdeen, highlights very nicely, I think, are the flows of carbon in and out of these systems, and some of the environmental drivers, including temperature, which can change these long-term stores. So as has already been highlighted, we will also need to understand the effect of future climate change on greenhouse gas emission and sequestration into these systems. And of course, in the context of sea level, these are habitats at sea level, they're also at risk from sea level rise. So we'll also have to think about management interventions for our coastlines. Should our coastlines be fixed? Do we need to allow for the inland migration of these habitats as sea levels continue to rise? And we know whatever we do through climate mitigation action, that the concentration of greenhouse gases in our atmosphere will continue through global warming to drive sea level rise for some considerable time. So this is an important issue for the management of these habitats. So a final thought, as we approach COP26 in less than a month now, we need to be working in partnerships. We need to work with governments. I would argue that that's increasingly important, and that I think blue carbon, as a very small part of this puzzle, offers an opportunity here in the UK and overseas to work with government, our devolved administrations, in a new commitment to nature. And this is a commitment that can help us tackle the twin issues of climate change and biodiversity loss. And it's one in which I think we need to engage a new audience. And I hope that some of you on the call today will have the skills to help us do that. Thank you.
Thank you very much, Bill. If I can invite all our panel members back on video, that would be great. Thank you very much, all of you. So we haven't had many questions coming through. So please, if you have any, just use still time to put them on the Q&A. I think we have time for one or two general questions, or if you have something specific, we can also address those. So I guess as a general question to all our panel members, what is the message we need to give to world leader for COP26, and what do you want to see happen after as an outcome of COP26? Cécile, do you want to start?
Okay, yeah, that's a big question. There's a lot that needs to come out of COP26. I think the main focus is of this year is raising ambition for countries, and everyone's been hearing that again and again. In terms of nature-based solutions, I think clear guidance, we need clearer guidance from the Paris Agreement rulebook on what are nature-based solutions. I mean, the term nature-based solutions is not included in the rulebook at the moment. So just introducing that concept. The concept of nature-based solutions differs to what's there at the moment, in that we're looking at biodiversity as well as climate mitigation and adaptation, as well as human well-being as metrics of success for these projects. So we're looking at this more holistically than we have before. And we've learned from past experience that focusing on carbon, for example, as the main metric of success can be dangerous and can have negative consequences. So there, clear guidance from the Paris Agreement rulebook on nature-based solutions.
Pete, yeah.
Yeah, so I want to see a commitment to nature-based solutions in countries' NDCs, their naturally determined contributions. So part of their ambition, of course, we want them to decarbonise as quickly as possible, but I'd also like to see commitments for at least a component of those to be nature-based solutions for all countries to be asked to consider that. And the other big thing that's really important is that in 2010, the richest nations promised $100 billion of finance to the global south, to developing countries. And we know that a lot of the potential for nature-based solutions lies in these developing countries. So we're not going to be able to do that unless we get the flow of finance. So I think it's a really big, important outcome of COP26 would be to see that $100 billion per year flowing from the global north to the global south. Not all of that will be for nature-based solutions, of course, but that's the big thing needed. We share the same atmosphere, so we all need to do it, and a lot of that potential is in the global south. So we need to finance them adequately.
Bill, yeah.
Just really quickly, I would acknowledge and celebrate nature as one of 5 key themes for COP26. I think we should encourage and support that, and highlight, I think, that the pandemic has shown us our intimate connection with nature, and that if we can work around these nature-based solutions, I think many of the other actions will follow. And I think this is an area where ambition is extremely important and leadership important as well.
Well, thank you very much. Yes, a lot of it is, sort of a condensation of what you've been telling us this morning. So it's fascinating, and hopefully the messages will get through. I suppose to be faithful to the theme of our series, I'd like to ask you what type of skills and chemistry skills you think we should give to students nowadays if they want to work and understand, to work in this area and understand carbon in ecosystem better. Pete, maybe do you want to go first?
Yeah, so I'm a biogeochemist, so I work in that area. So I need to understand carbon and nitrogen flows to understand the greenhouse gas emissions. But we also need people who understand biodiversity. So we can't do it in isolation. We have to learn to work in multidisciplinary teams, correct? But for anybody working in chemistry, an understanding of the natural biogeochemical cycles is a great place to start.
Yeah, I've got a bit of a pet peeve around this zero carbon phrase, because this would be interesting to have a zero carbon planet, right? There wouldn't be much things happening. So Bill or Cécile, is there anything else you'd like to add to that? Yes, Cécile?
Yeah, I just wanted to add that I started off as an ecosystem scientist, so looking at the carbon dynamics of tropical forests, and over the years, I've realized, as Pete said, the huge importance of looking at this holistically and understanding the ecology, the biodiversity side, but also the social side, and not we just tend to focus on what we're studying and focus on what our PhD is asking, but it is so important to take this as a whole and to understand the implications of your research.
And as scientists, sometimes it's easy to forget the other dimension. I think that's something we need to teach students really early on as well. Absolutely. Bill?
Yeah, just a slightly more detailed response, but in my field in particular, I think improving the sort of biomarkers to understand the flows of carbon within these biogeochemical cycles is something that we would really benefit from. Having people with those skills and expertise to contribute to these efforts would be really valuable.
Great, thank you very much. This has been really, really fascinating, and it's going to be you're all going to be able to catch up again on YouTube. So I think it's only left to me now to thanks the panel members this morning. Thank you very much, and thanks for our audience to join in. I think we'll now just have to wait until we're taken offline. So I hope everybody has a lovely rest of their day.
Thank you.
The chemical sciences are at the heart of sustainability solutions. Sustainability, powered by chemistry.